Alright, today's notes consist of our continuing with our laws of exponents. So we're going to look at two more laws of the exponents. So the first one, what we're thinking of is a power of a power. So if we had 2 to the third to the fourth power, so we have 2 to the third to the fourth power. Well, we could say it's 2 to the third, 2 to the third, 2 to the third, 2 to the third, because that's 4. This 4 here means we have 1, 2, 3, 4 of them. Well, then we could say that this is 2 times 2 times 2, and 2 times 2 times 2, and 2 times 2 times 2, and 2 times 2 times 2. We can write all that out, and then we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 2's. So now I have 2 to the 12th power. Well, the next one, we have y to the second to the fifth. Well, I can take this and say, well, y to the second to the fifth. Well, I need to have y to the second 5 times. So I can write this out 5 times. So y to the second, y to the second, y to the second, 5 times. Well, 2 plus 2 plus 2 plus 2 plus 2 will give me y to the 10th. Well, is there an easier way that I can multiply a power of a power? Well, when we think about this, 2 plus 2 plus 2 plus 2 plus 2, that's like saying 2, because I'm repeating this 2 times, I'm doing it 1, 2, 3, 4, 5 times. So that's 2, my exponent, times 5, because that's how many times I did. So what we're really doing is we're multiplying these two numbers. Same thing here. We have 2 to the third to the fourth. Well, I have 2 to the third, 1, 2, 3, 4. So I can multiply 3, 1, 2, 3, 4 times. 3 times 4 gives me that 12. So what we can do is we can multiply the exponents. And an exponential expression raised to a power is equal to the base. Alright, the base, this is the base, raised to the power of the product of the exponents. So it's raised to the power of the product, so it means we're going to multiply the two exponents. Now, why does this property work? Well, we have 3 to the 8th to the 4th. Well, we have 3 to the 8th, 3 to the 8th, 3 to the 8th, 3 to the 8th, and we can add 8 plus 8 plus 8, which is the same as saying 8 times 4. So if we look at a few examples, well, what we have 4 to the 7th to the 3rd, well, the long way is to say, well, I can have 4 to the 7th 3 times. Well, that means 7 times 3. And 7 times 3 is 21. So 4 to the 21st power. 13 to the second to the fourth. Well, we can once again say this is 13 to the second. And we can say that we do this 4 times. Well, 13 to the 2 times 4. Give me 13 to the 8th power. And if we continue with this, well, we have r to the 8th. Now if I write this 5 times, r to the 8th, r to the 8th, r to the 8th, r to the 8th, well, that's going to be r to the 8, 1, 2, 3 times 5, which will be r to the 40th. And then I can start to look at this and say, well, this is going to be 10 to the 6th times 2. Well, 6 times 2, 10 to the 12th. X to the 3 times 5. Well, x to the 3 times 5 will give me x to the 15th. And now we have 2 and then 2 to the 4th to the 2nd. Well, what we know is that this is 2 to the 1st here. And then this one, I'm going to have times. Now, I'm going to do 2 to the 4th times 2 to the 2nd, which will give me 2 to the 1st times 2 to the 8th, and then we can add these two exponents. Now we're not multiplying these because this is not a power raised to a power. So this is 2 to the 1st times 2 to the 8th, so that's 1 plus 8, which is 2 to the 9th power. Now this last set down here, we have n to the 2nd times n to the 3rd to the 2nd. Well, we can put everything inside the parenthesis together. So this is going to be n to the 5th to the 2nd, and then we have n to the 5th times 2, which is n to the 10th. Now another way we could do this is we can actually distribute the 4 to both of these. So I can say that this is going to be 9 to the 6 times 4 times 9 to the 3 times 4. Well, 6 times 4 is 24 times 3 times 4 is 12, and then we add 24 plus 12, so this is going to be 9 to the 36th. You could also put them together and got 9 to the 6 plus 3 is 9th, and then multiplied it by 4 and got 9 to the 36th also. And now here, well, what we want to do here is we want to distribute this. We want to do the first one, so this is going to be x to the 2 times 3, well, times x to the 2 times 0. 2 times 3 is going to give me 6. 2 times 0 is going to give me 0. If I add 6 plus 0, we simply get 6. X to the 6th. And then if we look at our next thing, negative exponents. Now, if I want to simplify this one using our quotient rule, well, what I can say is that this is going to be 5 to the 2nd minus the 5th. Well, 2 minus 5 is 5 to the negative 3rd. So 5 to the negative 3rd. We subtract, when we're dividing our exponents, we subtract our exponents. Like bases, subtract the exponents. Now, expanded form, well, 5 times 5, I have 2 of them. 1, 2, 3, 4, and now here I have 5 of them. Well, these cross off and these cross off. Well, remember what we talked about day 1? Well, when we cross these off, I really replace these with 1s. So I'm replacing these with 1s because 5 divided by 5 is just 1. Well, 1 times 1 will give me 1, and then 1 times 1, and then I have 5 to the 3rd. So 5 to the 3rd, so it's 1 over 5 to the 3rd. Well, what's our observation? Well, what we can say is that we did the same problem. We just did it 2 different ways. So what we can say is that these are the same thing. So 5 to the negative 3rd power is the same thing as 1 over 5 to the 3rd. Now, when we start dealing with exponents, we don't want to have negative exponents, so we have to get rid of that negative exponent. The way we get rid of it is we're going to make it into a fraction. So we're going to make our negative exponent into a fraction. So an exponential expression raised to a negative power, it's written as a fraction with a numerator of 1 and a denominator of the exponential expression with a positive exponent. So x to the negative p, well, numerator is 1, the denominator is the base with a positive exponent. 3 to the negative 5th, numerator of 1, base is 3 to the positive 5. And then why this works, here's some of our examples which we just went over and why it works. Now try these. Well, what we can say is that it already has a negative exponent, so we can say that this is the same as 7 to the negative 6, because 7 to the negative 6 is 1 over 7 to the 6. 1 over x to the 4th is the same thing as saying x to the negative 4th. 10 to the negative 8, well, that's going to be 1 over 10 to the positive 8. Now we have 1 over 5 to the negative 2nd. Well, that negative second's in a denominator, so what we can say is that this, instead of putting it in the denominator, it's just going to be 5 to the 2nd. M to the negative 3rd, well, we have 1 over m to the 3rd. Now when we simplify this, well, we have 3 minus 8, so this is 6 to the 3 minus 8, and 3 minus 8 is a negative 5. Well, we can't have a negative exponent, so what we want to do is put this into the denominator. So this is going to be 1 over 6 to the 5th power. Now what we do here is we're multiplying, so when we multiply these, our exponents, we add them. So this is going to be negative 3 plus 10. Well, this is a to the 7th. Now we can't have negative exponents. Well, we can simplify by subtracting. So this is going to be m to the negative 2 minus 2, which is m to the negative 4th. Well, we cannot have this negative exponent, so what we have to do is drop this into the denominator, so it's going to be 1 over m to the 4th. And then the last one, well, we're dividing, so what we can do is subtract our exponents. 3 minus negative 5, which is going to give us 8 to the 8th, which is our final answer. And that is our second law of exponents that we worked with today. So we looked at a power of a power and then negative exponents.